Hello and good evening, everyone. Hi, my name is Philly, and today what I'm going to be doing is trying to teach us or walk us through how to set up a $65 Kubernetes server on DigitalOcean. All right, so let me just jump right into it. Um, there are a couple of things you will need if you haven't got it installed. You'll need Homebrew. For those of you who are on Mac, and you should be able to install the Kube controller binary. Um, you can always use brew install. All right, I've got that already, so I don't think I need to do that. I'm just gonna check my version, make sure my version is fine. There we go. And you need a DigitalOcean account. I already have one, but if you don't have one, you can always go to DigitalOcean and sign up. It's quite simple and straightforward. You create an account. I've got a referral code if any of you are thinking about doing that. It's attached to this YouTube video. All right, so what we're going to start with is the Kubernetes Master. I think the master is what controls all the worker nodes, and the master is where all the control plane and the dashboards and everything that is required to run all the pods in the network. And I think that's the first bit of piece of the puzzle we're going to try and hack out first. So let's start off by creating a new node. For those of you, if you don't have a DigitalOcean account, as I mentioned earlier, just create one. And once you create one, add your card details, and you're good to go. Now, what you need to do is you need to create choose the container distributions using CoreOS. Make sure you use the latest stable version. For your Kubernetes master, I think the minimum recommended specs is 2 gig with 2 CPUs, and that's $15. Now remember, the aim is to try and keep this as affordable as possible for those of you who might want to keep this experimental, or if you're even taking it to production. A 2 gig processor, so 2 gig RAM and 2 virtual CPUs should be just fine. Leave the add block storage. We don't need it because we'll be using eventually in one of the other tutorials we'll be using block storage. Choose your region. For me, I'm going to use London. It's closest to me. Choose a region that's close to you so that your reply time requests will be routed quickly. Select private networking. Add an SSH key. If you don't have one, just add your public key here and give it a name. Once you give it a name, you add it and then select it so that you'll be able to SSH into the server later on. Give it a host name. In this case, I'm just going to call it K8, or I'll just call it K8 master node. Okay. Yeah, K8 master node. Now, there's no need to add any tag. You just need one droplet. What do I add? Yeah, and we create. It's great. All right, so while that's going on, I'm just gonna start creating the worker nodes immediately since I'm here. Let DigitalOcean start provisioning those droplets ahead of time. For the worker nodes, 2 gig RAM with 1 virtual CPU is fine. You can go the cheaper route, but the problem would be if you want to run a database workload, or you wanted to run like a Redis cache. Sometimes those can be resource intensive in terms of memory. So I think the minimum recommended would be 2 gig with 1 CPU. For your master, you can use 2 gig with 2 CPUs or 2 virtual CPU cycles. No need to add the block storage. Make sure you choose the same region that you chose when you were creating your master. As usual, select private networking, right? Select your key, and then give it a host name. In this, I'm going to call it K8 worker node. All right. Now, I want three droplets, so I'm just gonna change the version to 3. And DigitalOcean has this really nice auto, labeling trick that it does, and you don't have to type everything again. Now you need to give, this is important, you need to give it a tag that identify all these 3 nodes so that each node will have these tags attached to them. And once you're done, everything is all good, you click on create. The reason why it's good to have those tags is later on when we're creating a load balancer, we will need those load balancers to have them created. Okay, and we're good. The master node seems to be working okay. Just going to grab the IP here, and I'm going to go to my terminal. Right now, I have prepared a couple of scripts which would help us in this journey. So most of all the things that we will need are in my gist account. That's github.com/chickalfidi. Try and grab the install scripts. So just look for install-k8.sh. I could quickly run through what this script does. Essentially, it enables the Docker service, installs the container networking plugin, installs the kubelet service, the kubeadmin tool, which is what we're going to use to provision the Kubernetes cluster, starting the kubelet service and make sure it starts on reboot, adding all those binaries to the path, and then finally, this is an important bit, is to add DigitalOcean's private networking into the kubelets service so that all the pods will be able to route properly. So you'll be able to, SSH into the pods or execute commands or see the logs against the pods. If you don't take this last step, what would happen is your cluster will work fine, but you might not be able to see your logs, or you might not be able to execute any scripts from within them. All right, so I'm just going to grab a copy of that, and it's already somewhere on my system. So okay, I'm just going to try and keep this tutorial as short as possible. I want people to be able to okay. Yeah, and I think another thing that you can do is to actually view raw and just copy it right straight up. So I'm just going to create, just for the sake of this tutorial, so that okay. All right, just gonna inspect it one more time, and we are good. Okay, so now what we need to do is have that script installed on our Kubernetes Master, right? So what we're gonna do is gonna grab the IP of a master. Okay, and then gonna SSH into it. Now remember, the IP address, for CoreOS, the user that is needed is core. Okay, and script is installed. There we go. So what this command essentially is doing is telling Kubernetes, is telling the server that it should log on or SSH into SSH into the server and then run that install script. So all the commands that are there, which I already explained 10 minutes back or 2 minutes back, will actually get everything installed. So here we go. I'm going to run that. It's going to ask for the key. Oh, sorry, I think it's bash-s. There we go. Now what it's doing is it's SSH into our Kubernetes master, and it's installing, setting up, enabling Docker, it's just installing the kubeadmin tool, installing the kubelet service, and I think we're good to go. All right, so that is primed and ready to go. Now, what we need to do at the moment is to initialize the master. All right, but before we do that, what we're gonna do is we're gonna have to run the init scripts. Okay, I have the init scripts. I'm not sure. I'm just gonna check if I've got it here. Okay. Okay, I don't have it here, but I do have those init scripts. You could also check my tutorial. There's a tutorial. I think it's also on Medium, it's on GitHub. This is just a video version of that tutorial. Okay, so what we need to do is I'm just gonna enable what the master IP should be. Just gonna grab it here. Okay, and gonna grab, yeah, so just gonna initialize the master, right? So we're gonna SSH into this, and what we're gonna do is we're gonna initialize the master. Now, notice the code that I'm using, okay? I'm trying to grab the public IP. DigitalOcean has usually, remember we selected private networking, so DigitalOcean has the public IP and the private IP. You need to make sure that Kubernetes Master is bound to the public IP, else you won't be able to reach your cluster from outside the network, all right? So it's important that you use the public IP. However, if you don't have a problem and you want your cluster to be more secure, you can use the private IP. It means you'll always have to SSH into your server to be able to see your pods and see your logs and so on and so forth, right? That's great. Now, I just want to look at this command. It says kubeadmin init. Essentially what it's doing here is, remember, we're running as root. Okay, I think that's pretty obvious. We're telling it that the advertised IP should be the public address, and we're saying the pod network it should use is 10.244.0.0.16. Reason why we're using that network subnet is because what's happening is we're going to use Flannel overlay network. And that Flannel overlay network, as documented in the Kubernetes documentation, the Flannel network needs that network range, the IP address network range, and that's why we're passing that in it. If we didn't need it, we would need to pass that. So if we're using another network, maybe Weave or one of the other ones, I prefer Flannel for now. Well, no particular reason. Yeah. So it's still installing. It might take a minute or two for the control plane to get running because it's going to have to download the repository. Now, when it's done, take note of this last line. It's so important. With this is what we're going to use to get the other nodes joined onto the network. All right. So I'm just gonna find somewhere to keep it. All right. Just gonna keep it somewhere. Now, what I'm gonna do here is I'm going to try and get those same scripts running on each of those worker nodes. Okay, we've initialized the master. The master is good to go. Well, before we do that, let's configure our access to the master. So the first thing I'm going to do now is I'm going to, as a regular user on the master, I'm gonna run this code. Okay, we already have the kube config here. All right, and there we go. Now we should be able to see our nodes. All right, notice the master is there. I'm saying in not ready mode in version 1.10.2. Okay, so which means everything is okay so far. All right, so now what I think we need to do is also now configure access to our cluster. So we're going to log out from the cluster, and what I'm going to ask you guys to do is to do this. So you're going to secure file copy, all right, the master IP, okay, and then we're going to get location of where that IP is, which is in the home folder, in the queue, and the config. And we're going to copy to our own home folder, right? And the reason why we're doing this is so that we can have access to it. But remember, for those of you who are experienced, we already have, I already have another cube config, and if I download that, it will override it. So I'm just going to use test, and that's what it's going to do. And now it's got the file. So right now, all I have to do is use this syntax. You may not have to, but in my case, I have to. Okay, to get the nodes. Okay, everything's fine, so it's great. Great. So every command I have to run against the kube controller binary, I have to use kubeconfig. For those of you, you know what? For the sake of this tutorial, what I'm gonna do is, so that I don't confuse anyone, is I'm gonna go to this folder. I'm gonna clone my original config, copy it, back up. All right, then I'm gonna remove the old one, and I'm gonna move config first tests to config, and sweet. So now if I run the get nodes, it should default. Sweet. So we're good. We're golden. All right. Now let's do exactly the same thing for worker nodes. All right. We need to install everything we just installed on the server and the worker nodes. So I'm just gonna find what I did earlier on. Okay. Here we go. Okay. Okay, great. So now we have Kubernetes installed on all the networks. All right, now what we're gonna do at this point is we've already installed the CNI container plugin. So what we need to do at this moment is to actually add the pod network plugin. Right? I don't have a gist, but I have the link for the tutorial, which has the exact link, which should be there we go. So It's quite simple. We have already configured access to our cluster. Just gonna get the nodes just to be sure. Okay, now I have to enable the bridge also, and there we go. Great. Alright, remember this step is important. You need to install this network before you join the nodes. The last time I did it the other way around, I feel for some strange reason didn't get it to work for quite some time. But, notice that it's in ready state. So all we now have to do is see pods running. Notice that the kubedns is still pending, and it will remain in pending state until all the 3 nodes join. It needs 3 nodes individually to get to work. Right now, remember what I talked about the join code. So you need to run this on every single node. All right, and what we're going to do is we're going to get it to join the cluster. All right. Now, for each node, just going to SSH the core as usual. Add the node IP. I'm going to start with the first one, which is my DigitalOcean account. You only need to do this for the worker nodes, remember. Okay. And I'm going to get decode. The thing is you can execute it without actually logging in. Now, if you are trying to log on, if you're trying to join this code or use this join command, and this is your token. If your token is expired, if you're getting any error saying you cannot join because the token is expired or what have you, you can log on to your server, to your master IP, and run this command. Now what this command is going to do is going to generate a new token for you. Kube admin token create. This will generate a new token for you. Okay, I could just generate it. I'm not going to use it, but it just shows the token and it prints it out to the command line. But the old token is still valid, so we're just going to use that. Now, I'm going to run this on the other 2 nodes as well. Just going to grab their IPs. So work in node 1. Run that to join the network, and then I'm going to wait for the second one. There we go. No issues. How do I know there are no issues? I'm going to point that out in a bit. It says this node has joined the cluster. It says this tells me that everything worked okay. Okay. Now, if this works successfully, we should have 3 nodes plus 1 master ready to go in my Kubernetes cluster. Okay, so one is still saying not ready. Just need to give it some time. Let's give it some more time. Great. All right, so just going to get the pods in the cluster again. Great. As you can see, we have 3 DNS pods running on 3 different worker nodes. We have a Flannel worker plugin running on all the nodes as well, including the master, so we're good to go. Now, we actually have a working Kubernetes cluster. So if you got to this point without any issues, congratulations. All right. Now, we need to install Nginx ingress. And what the ingress does for us is that it gives us access. It gives us access to should I say, pardon, let me gather my thoughts. So it gives us access to run Ingress resources. All right, gives us access to deploy um, a node port service, which eventually our load balancer will use. So we're just going to paste that code and just going to run it. Oh crap! Apologies, guys. Yeah, I'm supposed to run this. It's dumb mistake. Pardon my. Now remember, our load balancer, sorry, our Nginx controller is installed using role-based access control, which is the default enabled for new Kubernetes clusters, I think from version 1.8 and above, or 1.9. So if you shouldn't be alarmed, all right? It comes by default now. So this is already pre-configured to use role-based access control, all right? Now, to be sure that what we wanted is done, I'm just going to get the service in the Ingress Nginx namespace. All right, so this is what you need to take note of. All right, this too is gonna. What we're gonna do now is we're gonna configure a load balancer. But before we do that, we need to make sure that our service works. So how do we confirm that? How we do that is we go to each worker IP. Okay, and for port 80, we take the port. All right. Oh, pardon me. It's 32060. There we go. So as long as you see the default backend at this point, you are in the clear. It means you've done everything right so far. We need to make sure that all the IPs are in the same boat. Yeah, and just gonna check the last one there. There we go. To be honest, if you could also check the master node, but we're not going to use the master node rotation. This is just to make sure that everything works okay. So we're good. Now, we have a fully working cluster. We have the Nginx installed, Nginx Ingress installed. We just need to configure our load balancer that will route robin requests to all our nodes as the pods get deployed. Now, DigitalOcean has inbuilt load balancer. So just go to networking, go to load. Okay. So we're going to create a new load balancer. Let's call it, yeah, it needs to be in the same region. All right. Now, this is what it's important. For forwarding rules, you need to set up HTTP and HTTPS. All right. Make sure the certificate is passed through. Now, on the port here, what we're going to do is we're going to use the mapped port 80 for the node port service. All right. And for HTTPS, we're going to use the map port 31949. 31949. And then in the advanced settings, you need to make sure the health check points to port 80. Your own node port, and make sure it's TCP. For some strange reason, I don't know why, but it needs to be TCP. It didn't reach it on HTTP the first time I configured it, but I guess maybe it's something on my part. Now give it a name. K8 master worker, I don't know, LB. Alright, create the load balancer, and it's created the load balancer, right? Now we need to choose the droplets. Now remember, we need for it to wait. So while it's creating, we need to remember when we were creating the worker nodes, we added a tag K8 worker nodes. So this is how the load balancer will find the nodes and put them in rotation. it's going to use those tags we assigned them earlier on. All right. I know that you could also add each of the droplets by name individually, but the reason why it's always good to use a tag is if tomorrow you create a new worker node and it joins the network, all you have to do is assign the tag, and once you've installed Kubernetes on it successfully, what would happen is it will automatically get it will automatically join the load balancer and put itself in rotation. So we're going to give it the worker node, which is what the tag that we used, and I'm just going to give it some time. All right, I'm going to try and see if I can get load balancer IP. There we go. So right now it's round robin through the node service ports for every worker node, and the load balancer is healthy and in rotation. That's great. All right, so if you've gotten to this point, great milestone achieved. What we're going to work on next is a simple deployment to make sure that our service works. Now, but before then, what I'm going to do is I'm going to go to a domain, a simple domain that I have, and I'm going to point that domain to my new load balancer IP. All right, I'm just going to give it, just call it, what is it? I have a domain here. Okay, just going to call it imchica.com. There we go. All right, just going to create a new, we'll just call it K8. It's going to point to my load balancer IP. That's the new one. Give it a lower time to live so it can quickly get into rotation. There we go. Now, I believe if I go to k8.imchica.com, there we go. All right, see how easy it is? Now, I have mapped this domain. So every subdomain of this domain is going to be mapped to my global Nginx resource. So what I'm going to do right now is I'm going to do a sample deployment. All right, and just go to my gist and look for echo server. The raw file is there. What we're going to do is we're going to get that file. All right, and I'm going to get it now. Okay, great, and I'm going to open it so that I can modify it. It's a template, remember. All right, so it says create this deployment. Or I need to update that file. So it's gonna update it later on, but it needs to have a namespace as well. Okay, so it's gonna create the namespace. Okay, it's gonna create 3 replicas. I'm gonna use the Google container. It's gonna create a service, and then in the ingress bit, this is the important bit, right? I'm gonna map that to echo.k8.imchica.com. Remember, everything here is fresh. I've not pre-configured everything. You could look at the YAML files. You can see how they work. And this is just to demonstrate how ingresses work. I probably will do a larger video tutorial on how ingresses work later on. So I'm just going to apply that. And there we go. And if everything goes according to plan, there we go. So let's check out the pods. Let's check out the pods in that namespace. Namespace is echo server. We have 3 pods. I'm still creating the containers. Okay. Okay, we have at least 1 running. All 3 are running now. Okay, great. So, what we're going to do, since we are here, we're going to go to the echo server. We're going to go there. Oh, Wait a minute. Something's wrong. Pardon me, guys. I think my DNS server's out there. Oh, sorry. That's my bad. I forgot to add a second one, which is anything at, no, it's a CNAME record, which should be star dot, I guess. Oh no, sorry. This should be star dot. No, so this is not the right record. It should be star dot k8 at k8 as well. Guys, it's good that you saw me do this because this can easily happen to anyone. Alright, so alright, voila. Alright, so if you refresh that, you see it's going to go in round robin format to every single IP in the network. All right, so oh, I can turn this off. Yeah. Great. So now we just deployed a simple service. We have put everything in rotation, and next I'm going to do in this series is to include a persistent volume support using DigitalOcean's block storage, the volumes. I'm also going to have in Helm installed. I'm going to have the Kubernetes dashboard installed. I'm going to install Let's Encrypt so that we can run automatic SSL certificates attached to our deployments. All right. If this was a test tutorial and you found this helpful, please let me know. If you're having any issues, please leave a comment. Let me know as well. Thank you guys for watching. Cheers.